Okay, so this video is going to introduce factoring. Okay, now we're going to start factoring by factoring out what we call greatest common factors. All right, when you have two or more terms, we want to look and see, do they share something? Do they have any values in common? Do they have any numbers in common? Do they have any variables in common? Is there a combination of both of those things that they have in common? Okay, and if they do, we want to factor or divide out what that common expression is. Okay. Now, when we factor out, your answer is going to be the product of whatever you've factored out and what's left over, okay, what remains after that factoring process, all right? So let's look at number one here. We want to factor this binomial. It's 3x squared plus 15x. So first thing you want to do is you want to look for numbers, okay, numerical factors that 3 and 15 have in common, okay? So they are both divisible by 3, okay? 3 is divisible by 3. 15 is divisible by 3. So that's going to be a part of my GCF, my greatest common factor. Now we want to look at variables, okay? X squared is here, x to the first is here. So this one has 2 x's, this term has 1x, so in common they have 1x, okay? So both terms have 1x in common, okay? So what that means is 3 and x, 3x is going to be what we call our greatest common factor. And this is what we want to divide each of these terms by in order to factor. Okay, so let's do that. So we want to divide 3x squared by our GCF of 3x, and we also want to divide 15x by 3x. Okay, so if you'll notice, these 3's cancel out. X squared over x is going to be 1x. Okay, so when I divide 3x squared by 3x, I get 1x. When I divide 15x by 3x, well, these x's cancel out. I'm left with 15 over 3, which is 5. So this piece simplifies to 1x. This piece simplifies to 5. So that leaves me with x plus 5. Okay? So even though we factor out that 3x, it still has to be part of our expression. Okay? Remember, our answer is going to be a product of the GCF, in this case 3x, and what remains, which was x plus 5. So I'm going to multiply 3x and x plus 5 to get my answer, okay? So 3x times x plus 5, okay? Now, you always want to check your work. We can check our work by applying the distributive property. So what you started with and what you ended with have to be equivalent. So you want to multiply 3x times x. Well, that gives you 3x squared. You want to multiply 3x times 5. Well, that gives you 15x. So what that tells us is this factored expression is equivalent to the binomial that we began with, okay? In certain cases, this is going to be very useful for us as we move forward and we're solving quadratics and we're solving different types of functions or graphing those functions, okay? So being able to factor is a huge part of what you're going to do from this point forward. Now, move on to number 2. Pause the video here and give that one a try, and then come back and check your work. All right, so hopefully you got that one right, but let's check it out, okay? So again, we want to look for numeric factors in common first. So 5, positive 35, and negative 25. Well, those are all divisible by 5, okay? Now we want to look for variables they have in common. So in each of these terms, I've got 2 variables. So I'm going to start, let's go in alphabetical order. I'm going to start with the x's, okay? There's x to the 3rd power here, so 3 x's are there, 2 x's are there, and 1 x is there. So the greatest amount of x's they have in common is 1, okay? If I try to take out x squared, for example, well, this doesn't have x squared, so I can't take that out, okay? So the most that I can take out, the most that they have in common is just this 1x, okay? Let's look at y's next. Well, this one's y squared, y cubed, y to the 4th. So the most amount that they have in common is this y squared, okay? If I only take out y to the 1st, then each of these terms is still going to have a y there. So I want to take out the greatest common factor, not just any common factor, okay? So they all have a y squared in common, all right? So what that means is the product of all of these pieces here, 5x and y squared, is going to be my greatest common factor, okay? So 5xy squared is the greatest common factor. This is going to be a part of my answer when I complete this problem. Okay, so we're going to divide each of these 3 terms by that GCF, and that looks like this, okay? So 5x cubed y squared divided by 5xy squared. 35x squared y cubed divided by our GCF. And then negative 25xy to the fourth divided by our GCF, okay? So what that leaves me with, the 5's cancel. This is x cubed over x, which means there's an x squared left there. And then these cancel because they're the same. So this first piece here is going to simplify to x squared, okay? Second part, 35 over 5 is 7. X squared over x is x. Y cubed over y squared is y. So this piece simplifies to 7xy. And finally, 25 over 5 is 5. These x's cancel out. Y to the fourth over y squared is y squared, okay? So this is going to be, this piece is going to be negative 5y squared. So when I do that division, this simplifies to x squared. This part simplifies to 7xy. And this piece simplifies to negative 5y squared, okay? So remember, when we factor out this GCF, it's going to be part of our answer. This is going to be the other part of our answer, so we put those together. And when I completely factor this trinomial up here, I get 5xy squared times the trinomial here, x squared plus 7xy minus 5y squared, okay? As always, you want to check your work. We want to use the distributive property, okay? So we're going to distribute this expression times these three terms. And when you do that, you should get the trinomial that you started with, and you do, okay? So this is the correct answer. So that's how you factor expressions using a greatest common factor.